All right, science detectives, welcome. Today, we are on the case of a pretty fascinating mystery. It's a transformation that happens all around us, every single day, but how it works, well, that's the real puzzle we're here to solve.
I mean, think about it. It sounds kind of impossible, right? How can a huge, solid piece of rock become the soft ground that we walk on? Well, every good mystery has a solution, and I promise, by the end of this, you will have cracked the case. So, the secret to solving our big rock mystery actually starts with a really simple idea. Change is happening everywhere, all the time. From a flower blooming to a banana getting brown spots, the world is constantly in motion. And these little everyday changes, they hold the clues we need.
Okay, so to figure out our puzzle, you gotta understand that there are two main ways that things can change. And that brings us to our very first clue.
This is what we call a physical change. It's all about changing how something looks, its shape, its size, or even its state, like when ice melts into water. But here's the most important part. The stuff it's made of stays exactly the same. Let's use a super simple example. Imagine you take a solid piece of chalk and you just grind it down into a really fine powder.
Even though it looks totally different, if you put that powder under a microscope, guess what? It's still made of chalk molecules. No new substance was created, just a change in its shape. That's a classic physical change.
Or here's another one for you. You take a sheet of paper and just snip it into a bunch of tiny pieces. It's a different shape, for sure, but each one of those little bits is still, fundamentally, paper. The substance itself hasn't changed at all. So, same stuff, new look. That's our first clue, a physical change. Now for our second clue, which involves a much deeper, more permanent kind of transformation. This isn't just a costume change. This is where things get a whole new identity.
And this is a chemical change. This is where things get really interesting. See, in a chemical change, you don't just change how something looks. You change what it is. You end up with a brand new substance with totally new properties.
The classic example is burning wood in a campfire. You start with a log, right? But after it burns, what's left? You've got ash. And what was released into the air? Smoke and gases. Now, you can't take that ash and smoke and somehow turn it back into the log. Why? Because it's not wood anymore. It has chemically changed into new substances. So here's the bottom line, the number one rule for our investigation. In a physical change, no new substance is formed. In a chemical change, a totally new substance appears. This single difference is the key to solving our entire mystery.
Okay, detectives, we have our clues. We know all about physical changes and all about chemical changes. Now, let's go back to our original question and finally crack this case. So what do you think? Based on what we've just learned, which category does this fall into? Is it just a change in appearance, or is something completely new being made here? And the answer is, plot twist, it's both. The process of a rock turning into soil actually involves physical and chemical changes working together as a team. And scientists call this whole process weathering. The process happens in two ways, often at the same time. First, you have physical weathering. That's just forces like wind and water physically breaking the big rock down into smaller pieces. You might have heard this called erosion. But while that's happening, chemical weathering is also attacking the rock. Rainwater and air react with the minerals inside, creating new substances, like rust, which makes the rock crumble from the inside out. And that brings us to our solution. It's this amazing combination of physical and chemical changes, this process of weathering, that over thousands and thousands of years breaks down even the mightiest rocks into the very soil that allows plants and all kinds of life to grow. So we've solved the mystery. But now that you're an expert on physical and chemical changes, it's your turn to be the detective.
So look around your world. The next time you see ice melting in a glass, you'll know that's a physical change. When you see a cake baking in the oven, you'll know that's a chemical change. The world is full of these scientific mysteries, and now you have the clues to solve them. Thanks for joining the investigation.